Hello, so today we're going to talk about how Seapath is leveraging Sr-Iov. Sr-Iov is a network virtualization technology that allows a network interface, a physical network interface, to be shared directly to multiple guests. In this example, we're going to share multiple interfaces to a single guest, and the idea is that the physical interface is directly given to the guest, and so there is no interference of the host kernel, no software involved, and so we hope for good performance using this technology. So as usual, when you want to configure something in Seapath, the idea is to go to your inventory. So let's open the inventory and see the variables that are useful for Sr-Iov. So there are two. The first one is the driver you're going to use, which is usually common around the nodes. So we write it in the hypervisors section, and in our case, we're going to use the IGB driver. And then on each and every host, you may add a dictionary, Sr-Iov, with the number of VFs of virtual function you want for any physical interface that supports Sr-Iov. In our case, we are going to create 2 VFs on this interface and 2 VFs on this interface. Let's first have a look at this interface. No VFs are created. The idea is that the first playbook will insert the driver if needed, create the configuration for the VFs. And the second playbook, a networking playbook, will make those virtual functions available to libvirt. And then we're going to configure a VM to use those virtual functions. Let's see. First, we are going to run the prerequisite playbook to create the VMs. The VF, sorry. So what has this playbook done? It has created a file in the sysfsd directory, sriov.conf, to create the required number of VFs. If we run the same command as before, we can see that now both interfaces have 2 VFs usable by VMs on the systems. To do that, we are going to expose those VMs to libvirt using network pools. First, let's have a look at the networking in libvirt. We have absolutely nothing. Let's run the network playbook to create the networking linked to those newly created VFs. So as you can see in the end of the playbook, the networking seems to have been created. So let's run this netlist command again, and we can see that we have one network pool per interface. So we know that this pool it will be able to use any VM available for any VM that asks for it. How does the VM ask for it, you may ask? Well, let's have a look at a VM. An XML VM, and in the networking section, in the device section, this is how you use the newly network pool pools that have been created. So basically you create a an interface of type network. You can set a MAC address and the source network, which is the key, and eventually the PCI you want to connect the network card to. In that case, the 5 and 6 will be useful because we can see what interface is which. So we can see that, for instance, the 41 MAC address is connected to the bus 5, and the 42 MAC address is connected to the bus 6. We'll be able to check that in a minute. Let's restart the VM. Then let's monitor how it's booting with a console operation. Oops, sorry, that mistake of my part. Let's monitor the booting process. So the VM is booting, and in a few seconds we'll be able to connect to it using SSH. Let's wait a minute. Okay, so we are connected to the VM, and we can see now we have the bus 5, so ENP5 S0, and bus 6, ENP6 S0. The MAC address match. So yeah, those interfaces in the VM are actually a virtual function of a physical interface on the host. The communication will be direct using PCI pass-through, or Sr-Iov, and so we expect very, very nice performance on both those interfaces. I hope this was clear and that it showed that Seapath can leverage Sr-Iov easily enough.